Gio, nice to see you this morning.
Glad to be on.
Okay, so what are the implications for mankind now that we have found with that rocket that we shot into the Earth or the surface of the moon, that we found this water there? What are the implications for us?
This is a potential game changer. NASA has hit pay dirt. You realize that ice is worth 5 times, pound for pound, 5 times the value of gold on the moon. This could change the way we view space exploration, living off the land, using the ice of the moon.
And because if we then go to the moon, we could then set up permanent bases there for deeper exploration. Is that right?
That's right. Hydrogen could be used for rocket fuel. The oxygen in the water could be used for breathing. Water could be purified and drunk. And also, water is a good shielding against solar flares and cosmic rays in outer space. This was an $80 million gamble. It's simply paid off in spades.
So is this politically important, though, for President Obama? A lot of people saying, well, how can we afford this, right? That mission where we blasted that thing into the surface cost $80 million. Does this gamble pay off politically for President Obama?
It puts pressure on Obama because the Augustine report has said more or less the Yanks are not coming. We're not going to go to the moon. We're not going to go to Mars with the present budget. If we can shave off billions by finding water on the moon and, quote, living off the land, that cuts the cost of the space program. And that puts pressure on Obama to perhaps give the green light for a manned space mission to the moon.
Why, when we watch that video, I mean, universally, I mean, even here on the show, we were watching it live here on Fox and Friends, and you should have seen what people were saying in the Twitter sphere and on Facebook. People were saying it was kind of a dud. We didn't see much. There wasn't much to see. But it was really what the scientists then gleaned a few days later that was really important, right?
Back in October, NASA got a black eye because it was a dud. We were expecting the money shot. Well, for a scientist, this is the money shot. We got sensors showing 24 gallons of water in a crater 60 feet across. That's huge. 1% water in the composition of underground rock.
And it was expected to be much like what we saw on Jupiter. What with that comet or the, I forget which comet it was, or that asteroid.
Shoemaker-Levy?
Yeah, Shoemaker-Levy 9, whatever, smashed into Jupiter. We saw this massive explosion, and we learned quite a bit about the planet there, right?
We've been spoiled by Hollywood. We expect to have fireworks and all sorts of pyrotechnics take place. But space is different. We scientists are looking for the water. Follow the water. That's the mantra in the space program. Where there's water, there might be life, plus rocket fuel, air to breathe, water to drink. Water is really the stuff of life.
And, you know, for those people who, I always get sort of frustrated by this, but I think this is something that's wholly American about this idea of adventure, being an adventurous spirit, going out there and exploring the universe. And the money that we spend on the space program has massive implications. You see it all the time in your work, right?
Think of what happened when LBJ went on television to announce the fact that our first weather satellite in the 60s warned the great state of Texas that a hurricane was coming. Thousands of lives were saved. Billions of dollars of property damage were averted. And then LBJ announced, quote, the space program has paid for itself today.
Saving lives.
That's so true.
Yeah, and that spirit. Well, Michio Kaku is also launching a new show. You have a new show on the Science Channel starting in December. Tell us about that.
It's called Sci-Fi Science. Teleportation, ray guns, force fields, antimatter, warp drive, you name it. We cover it on the Science Channel December 1st, a weekly show. 12 episodes of everything you've seen on the silver screen.
Is it safe to say good geek stuff?
Yeah, it's geek-friendly.
Yeah, all right. Michio Kaku, I'm a fellow geek. I appreciate that. Nice to see you this morning. Good luck with the show.
Okay.
Life as we know it. NASA did a study and its findings are now out. We're not talking about global warming, a brand new government study on the very real destructive threat of solar storms. Check it out, the surface of the sun, a roiling mass of plasma and charged high energy particles. As we move to the launch pad, we can show exactly what we mean, escaping the surface of the sun and traveling through space to areas down here on Earth. Now, this giant fireball, if that ball hit the Earth and its magnetic shield, it would be devastating. I want to show you New York City at night. Times Square, drove through here at 8 o'clock last night. Streets are empty, but the electric power grid would be wiped out by the current. Lights and computers, transportation, hospitals, all would go down. The study warns it would be a disaster, far worse than anything we have seen before. The menace of these sunstorms poses a bigger threat to more high-tech and advanced countries like the U.S. Everything from our sewage systems to our Wall Street banks operate with our power grid. And a game-changing solar storm that could hit at any time. So how worried should we be? Sounds like we should be. Michio Kaku is an astrophysicist and author of The Physics of the Impossible. Sir, good morning to you. Welcome back here.
Glad to be on your show.
Now, what I'm reading here scares me to death. Should I be that way?
That's right. We're talking about a potential Katrina from outer space. Katrina caused about $100 billion in property damage. And unless we begin to make efforts now to reinforce our satellites and power grid, we could have something maybe 10 times bigger than Katrina, because we're talking about the loss of all electricity and all satellite activity. We'd be thrown 100 years back into the past.
Michio, has this happened before?
In 1859, we had a humongous storm that wiped out telegraph poles, and we tried to then estimate what kind of power could do that. And we now realize that we are very young in the space age. If something like the 1859 storm hit again, it would literally paralyze all the United States, not just for a day or an hour, but for months to years. Transformers would short circuit and burn out. Satellites would be fried to a crisp. And the sun, however, has these storms every 11 years. Every 11 years, the magnetic field flips. But in 2012, we do expect perhaps another big one.
Well, we have never before in our history, in human history for that matter, relied so much on technology as we do today. And that's part of what they found in the study, because we rely so much on our ability to communicate through our computers that they would all go down, which would handicap not just New York, but really the eastern half of the United States. That's what the study finds, which would be far worse than the blackout of New York from 4 years ago, Michio.
That's right. Those blackouts only last for a few hours to a day. But if you start to short circuit all the transformers and blow out the satellites and fry the communications grid, then you're talking about knocking out the United States for months before we can get enough rescue crews and repairmen to handle not just one city, but hundreds of cities around the United States.
You know, Michio, sometimes you come on here and you sound like the doctor of doom and gloom. Does something like this keep you up at night?
It does, and I think with Katrina, engineers knew that Katrina could happen, but they did nothing because they said that it's not going to happen while I'm around. Well, now we learned the lesson. You have to prepare for things, especially when you know that at some point it's inevitable that we're going to have another big one, like we had back in 1859, except this time we're totally dependent on
Yellowstone in northwest Wyoming, land of geysers, mountains, and lakes, is also sitting atop a super volcano. And it just took what scientists describe as a deep breath, causing miles of ground to rise dramatically. So what does this mean? Well, joining us right now is Michio Kaku. He is a physics professor at the City University of New York and the author of the upcoming book, Physics of the Future. Thanks so much for joining us.
Glad to be on.
So the last time this happened was 640,000 years ago. We're due?
We are due. Forget Yogi Bear. Okay, forget Old Faithful. It's sitting on top of a sleeping giant. Now, if you're sleeping next to an 800-pound gorilla, you monitor every burp, every snore of this gigantic gorilla, because when it blows, it could destroy the United States as we know it.
This is a pretty scary prospect. I want to just show people what we're talking about here when we talk about this super volcano, and we have a little thing to show you, a map with some of the details. So that's where it is. It's beneath Yellowstone. It's been there, as we know. I guess this has erupted 3 times in 2.1 million years. But what they're worried about is the fact that they say that the ground has started to swell in levels that they have not seen before, 10 inches in some places in the past year. What does that tell us?
It tells us that there is activity in this supervolcano, which erupts roughly every 600 million years. And the last eruption was 640 million years ago.
Oh, 640 million or 1,000?
1,000 years
Okay,
ago, I'm
okay.
sorry, right.
Because then we had some more time.
Then we have some more time, right. But that's what's making us very nervous, because the cycle time corresponds to the present-day era. So every single burp, murmur of this gigantic potential supervolcano, including the rise of the sea level, has to be watched very carefully.
All right, so when we talk about this, and we have pictures pictures of Mount St. Helen erupting back in 1980. Let's just show this right now. You say that an explosion with this supervolcano under Yellowstone, and there we're seeing the Mount St. Helens, would be 1,000 times bigger than this. What type of damage are we talking about here?
We're talking about immediate damage out to 100 miles from the site. That is total devastation, basically wiping out everything in sight. However, the real damage goes out to 500 miles if you include volcanic ash, poisonous gases, death of wildlife and vegetation, and that's a ring about 1,000 miles across. That's the heartline of America.
It would pretty much wipe out Earth as we know it?
It would wipe out the United States as we know it. And again, we don't want to panic anybody. It could happen tomorrow, or it could happen 100,000 years from now. It's black magic trying to predict exactly when it's going to blow, but we do know one thing. One day, it will blow.
And you say that something on this scale is what wiped out the dinosaurs.
65 million years ago, another supervolcano coincided with this meteor that hit Mexico, and we think it was a double whammy that knocked out the dinosaurs. So it's something that we take very seriously, but again, the cycle time is measured on the scale of hundreds of thousands of years.
Would there be anything we could do to prepare or to get people out? I mean, how much of a warning might we get with this eruption?
All you can do is run. You don't get much warning. What happens is the ground starts to rise, more and more earthquakes take place, more ash and volcanic gases start to be unleashed. That's about the only warning we get, because we do not have a good way to predict volcanic eruptions.
Are we getting a better way to do it, or are we just at the mercy of Mother Nature?
We're still clueless. We're still monitoring it very carefully, looking for the warning signs. That's why this sudden rise in the Earth, even though it's not immediately dangerous, is being looked at very carefully, because we have no experience with supervolcanoes. We've seen Mount St. Helens. We've seen Krakatoa. But a supervolcano erupting in our lifetime, we have no understanding of the scope of that thing. We just see the evidence of previous eruptions.
It's amazing. So you say it could be tomorrow, it could be in 100,000 years, but it's under there.
It's there, and it will happen. At one point, it will destroy North America as we know it.
Michio Kaku is a physicist and professor at City College of New York. This article is stunning. Is it overstated in any way?
No, the Cascadia Fault is an earthquake waiting to happen. We know it's going to happen with an energy 30 times the maximum energy of the San Andreas Fault. So Hollywood has us brainwashed into thinking the big one is going to be in California. No, the Cascadia Fault would pack energy 30 times the energy that the San Andreas Fault can muster.
The article speaks of a liquefaction of the Earth, that part of the Earth will turn to liquid.
That's right. We're talking about major energy surges inside the ground that'll cause it to liquefy. We've seen that in Japan. We saw that at Fukushima, and it's almost like quicksand. One day you're walking on solid ground, the next you're falling right into a quicksand.
This earthquake would last 4 minutes or more, the rattling and the shaking, and then within 15 minutes they estimate this wall of water. In the entire inundation zone, you could have water up to 100 feet high.
That's right, and in the inundation zone, we have 70,000 people that have almost no clue as to what could happen. You know, in Japan, you have to live with earthquakes every day. Children go through tests and drills. People are conscious of this. But in the Pacific Northwest, it barely rates on the radar screen.
There's something that happens before the shaking that we can sense, that sensors can pick up. That's an early warning system that they have all over Japan, especially in the north and in the Tokyo area. They've been trying to get it pushed through, look for money for it in the Seattle-Tacoma area, nothing.
That's right. Before the earthquake actually hits, there's a compression wave that is detected by animals, for example. Animals start to act very strange, and we've seen that happen before earthquakes. And then a minute, 2 minutes later, boom, you head for the hills because there's nothing left to do except to go to high ground.
You mentioned what this sort of event has caused in history.
That's right. In the year 1700, there was a massive earthquake and tsunami which surged over Japan. And then running the videotape backwards, you can actually see that in 1700 it originated with a Cascadia fault. And then we physicists can calculate the energy, the magnitude, the dynamics once we got these two events linked together. And that was only done in the last decade or so.
And you mentioned Mount Everest.
That's right. Mount Everest is also created by the collision of two faults, just like what we have here. The one fault going under, the other fault going over, and that created the Himalayan mountains. That created Mount Everest. That's the power packed by the subduction zone earthquake.
Okay. Averages of when things are going to happen are really not very reliable. I think they use by example, the difference between 4 and 6 is 2. I forget exactly how they did it. We can't be sure exactly when this is going to happen, but we're positive it's going to happen. If you lived in the Pacific Northwest, you had little kids, would you live there?
I'd think twice. I would have to drill them just like what they do in Japan, be part of their life in terms of having an emergency kit, where to go in case of an emergency, what to do, what frequencies to go to, and so on and so forth. And by the way, we know that this is going to happen because by simply drilling into the seafloor, we can see evidence of ancient tsunamis going back 10,000 years. And we've
There have
known
been how many over that period?
41, which means that the time between the cycles is about 240 years.
Wow.
And it's been 315 years since the last big one. Now, of course, this is not rigorous, it's not absolute. But according to this figure, we could be overdue for another big one.
Yeah, by many decades. It's nice to talk to you. Thank you. Really weird and scary.
That's right. And, you know, within the lifetime of some of our viewers, they may see Seattle and Portland destroyed.
It's a great article at The New Yorker. It's in this month's edition and spectacularly well written. And the facts that go along with it they're really sort of mind-numbing. See you soon. Thank you.
So there's this star, nearly 1,500 light years away from Earth. And we have this telescope that's been staring right at it for a number of years. But scientists say something strange keeps getting in between the telescope and the star. They can't figure out what it is. Let's bring in CBS News science contributor Michio Kaku. Okay, what is happening? Why is this star causing scientists to wonder in fascination what might be out there?
Well, we don't know, and this could be the biggest story of the past 500 years, bigger than the discovery of America by Columbus, or it could be the biggest wild goose chase since the Loch Ness Monster.
Okay, well, now you've given us a huge dichotomy of possibilities. Let's explain it. This is a star called KIC. I like to call it KIC, but it's KIC 8462852. That's its official name. The Kepler Space Telescope is out there. Can you explain why scientists and why space lovers are fascinated by what's happening with this?
This star is breaking all the rules. We have to rewrite astronomy textbooks. Basically, if a planet eclipses the mother star, goes in front of the mother star, starlight drops by maybe 1% at maximum. However, starlight has been dropping at 22%. There is a colossal, humongous object of some sort blocking the starlight from this star.
Okay, so imagine if you're in a movie theater and you see the spotlight coming from behind you, and on the stage what you're seeing is a huge nebulous rectangle of shadow, and you don't know what's causing the rectangle of shadow on the stage, right? Something like that. Okay, could it be an alien superstructure?
That's what we're speculating. We've ruled out all the usual suspects, rogue planets, comets, asteroids. What's left but Star Trek? We're talking about what is called a Type 2 civilization that could build a gigantic sphere, perhaps bigger than Jupiter, to absorb starlight. And this, of course, is right out of science fiction, but here we are staring at it, and we have no logical explanation other than to assume that perhaps just perhaps, is made by a civilization a few thousand years more advanced than ours, like the Federation of Planets.
Wait, does that put us back in like Cro-Magnon status?
Well, compared to them, yes. We are what is called a Type 0 civilization. We get our energy from oil and coal. Type 1 would be like Buck Rogers, planetary civilization. This civilization is stellar. They can manipulate the energy of a star if it pans out.
Okay, so I'm left baffled because they also spotted this star in 2009. This is October 2015. Why are we just talking about it now?
Because as Carl Sagan said, remarkable claims require remarkable proof. If you're going to say that this discovery ranks with the discovery of America by Columbus, if it's on that kind of scale, you better be sure that it's not some kind of hoax or some kind of dust on the telescope.
And if this potential hypothetical civilization is 1,000 years more advanced than we are, why haven't they made contact with us? Are we as human beings just not ready for that?
Well, if you go down a country road and see an anthill, do you go down to the ants and say, I bring you trinkets, I bring you beads, I give you nuclear energy, take me to your ant queen? Or you have this politically incorrect urge to step on a few of them?
Yeah, right. That's a very good point. It's equally as good as my theater metaphor.
Right.
I like both.
So why should they land on the White House lawn? We have nothing to offer them. If they can build an object bigger than Jupiter, I mean, we have nothing to offer them.
Are we going to get answers in our lifetime about this?
Well, next we're going to focus our radio telescope to see whether we can eavesdrop on their I Love Lucy. Maybe they too have, Leave It to Beaver and TV shows like that. So we're going to focus our radio efforts now on this star to see whether there's any regular radio emissions from that planet.
Oh, it's so exciting. Michio, thank you so much for joining us.
Yeah, my pleasure.
Michio Kaku, a physics professor at the City University of New York and really something of our earthquake experts. So obviously your expertise is needed today. Interestingly, the 110th anniversary of the 1906 earthquake that destroyed San Francisco. We're now seeing obviously earthquakes dominating the news cycle in the last 2 or 3 days, Ecuador and Japan. Given that we're talking about tectonic plates, are they at all connected?
The short answer is no. We're talking about the Pacific Ring of Fire, stretching from Latin America through California, up to Alaska, Russia, Japan, and down to the Philippines. However, there are linkages between nearby faults, like, for example, the Cascadia Fault off the coast of Seattle. It's linked to the San Andreas Fault, which you mentioned devastated San Francisco. So nearby faults can, in fact, be linked. So it's sort of like a wake-up call.
I was struck and was reading a great piece in the New Yorker about the Cascadia subduction zone. And essentially they were saying that they're on the clock up there. If you look at the last time it happened, that they are now overdue in that area, in the Pacific Northwest, for an earthquake. But you think that, and really I guess any seismologist will agree, that it's in northern Los Angeles where they should really be worried.
Yeah, earthquake prediction is like voodoo and magic. However, when you see the images from Ecuador and Japan, think of it as a dress rehearsal. There is a time bomb called the Cascadia Fault and the San Andreas Fault. Now, the cycle time for the San Andreas Fault is roughly, plus or minus, 150 years. And the last big one to hit Southern California was 1857. Meaning that, in some sense, according to one clock, we are overdue for a big one to hit the northern LA area. So most seismologists looking at the San Andreas Fault would say that the next place to have a break would be northern LA.
Because we're talking about the Earth's plate movements, why is it that earthquake prediction is still, in this day and age, with technology where it is, for so many other things, why is it still a sort of voodoo?
Well, we know that these fault lines scrape and move against each other at the rate of the rate at which your fingernails grow, about an inch every 6 months or so. And so they're very slow, but pressure is building up. And pressure is building up along the San Andreas. That's why people are very worried. We see pressure building up in Cascadia, pressure building up in the San Andreas Fault. And remember that property damage in case of a big earthquake could be on the level of $200 billion. Now, these are estimates done by the government itself. And again, no one knows when it's going to happen, but we know it's inevitable. It's not a question of if, it's a question of when, given the fact that these fault lines have been rubbing against each other for centuries.
As an LA native, I can say I've been through a few of these. The Whittier quake, you've seen the streets turn into a sort of liquid as it rolled through. Nothing too severe, of course. We've also seen earthquake preparedness taken to new levels in the Pacific Northwest, in San Francisco, where a lot of the buildings are base isolated, essentially on ball bearings. But how earthquake-proof is the northern Los Angeles area?
Not very. You've seen all the movies like San Andreas. They exaggerate. A tsunami is not going to hit San Francisco, for example, because it's a sliding fault, not a subduction fault. So Hollywood has exaggerated it. But you cannot exaggerate the enormous unpreparedness that will hit us when the earthquake actually hits. For example, Japan is the most earthquake-conscious country on the planet Earth. Children are schooled into the culture of earthquake warnings and prevention ever since they were little. And my father comes from southern Japan, not that far from the epicenter of that earthquake. And even then, we're talking about casualties. 10,000 troops have been mobilized, 20,000 troops have been mobilized in Japan, 10,000 troops have been mobilized in Ecuador. So even with all the plans we laid out, we're still seeing entire villages being flattened as a consequence.
The best laid plans are left looking like that when the magnitude is as high as it was. Dr. Michio Kaku, fascinating stuff. We appreciate your time today.
Thank you.